Have you ever met such problems in an AI vision project? Data annotation is time-consuming. Algorithm parameter adjustment is too difficult. And the model training cycle is long. Now, our VisionTrain can help you to deal with these problems. Quick start and easy to use. Extremely low learning curve to enable business personnel to get started quickly. High precision models. Trained models deliver exceptionally high detection accuracy. End-to-end model training. Seamless integration from data management to one-click deployment shortens project cycles. VisionTrain is a model training software developed to support Vision Master and AI hardware, such as smart cameras. It supports 7 training modules: image segmentation, character localization and recognition, image classification, target detection, image retrieval, instance segmentation, and unsupervised segmentation. Introduction to VT interface layout. 1. Data management. VT 2.3 version can load multiple datasets simultaneously. 2. Image management. Support to import, export, filter, sort, and delete images. 3. Label tools. Support rectangle, rotated rectangle, circle, and polygon tools. It also supports label undo, redo, and delete functions. 4. Image display. Show images and labels in this area. It also supports rotating images. 5. Image adjustment. Adjust image channels. Set whether to display labeling or inference results. And image zoom scale. 6. Label management, model training, model test, and evaluation. In this area, you can add labels, view label statistics, set model training parameters, perform model training, and conduct model validation. Training process. Next, we will take an object detection model as an example to provide a detailed introduction to the use of VisionTrain. Our goal is to identify all the samples in the image. Step 1. Create new dataset plus choose model type. Steps to create a new dataset. Enter a project name. Select a local saving path. Select a training type based on the application scenario. Step 2. Label image. 1. Label images. In Image Management Interface, it supports to add images directly or add folders. If the folder contains image annotation information, which can be used by the current algorithm module, the annotation information will also be imported when importing the folder. 2. Add labels in Label Management. Use label tools to mark information on the image. VisionTrain2.3 support rectangle, rotated rectangle, circle, and polygon tools to label images. Step 3. Configure model parameters. After labeling is finished, click the Train and Test tab to train the model. Under Train and Test, click Categorize Testing Sample Set and set the testing sample set proportion. Under Model Training area, users need to select the platform for importing the model. The trained model can only be imported into the corresponding platform. Otherwise, an error will occur. After image annotation is completed, the software will automatically recommend training parameters based on dataset characteristics. Users no longer need to manually calculate parameters such as resolution and iteration rounds based on the proportion of target images and image quantity, making the process more efficient, convenient, and accurate. Users can also manually configure training parameters. Model capability. Supports 4 options: ultra lightweight, normal, lightweight, and high accuracy. For specific differences, please refer to the table. Resolution. Used to set the size of the image after scaling. Choosing a smaller size can relatively improve algorithm processing efficiency. Selecting a larger resolution ensures that the trained model can still extract the position information of the target to be detected from the scaled image, even when the target size is small. Iteration. Set the number of rounds for the algorithm to train on the training set, with a default value of 150. Appropriately increasing the number of iterations can improve model reliability, but will extend training time. Angle mode. If enabled, the model will use data with angular features during training. Data enhancement. By adopting data enhancement, the model's generalization ability can be improved to a certain extent, but it may also reduce training efficiency. Generally, the default configuration is recommended. Step 4. Model test. After configuring the training parameters, click Start, and you can check the model training status in Model Management. Below the Model Training Progress bar, you can view the training parameters and loss curves. Once the model training is complete, you can view the generated model files. After model training is completed, you can select one or multiple images for partial test. Click Select Model to choose the model that needs to be tested and validated. Confidence sets the minimum confidence level for inference results. The confidence level represents the likelihood that the inference result belongs to the corresponding category. IOU sets the minimum overlap ratio between the inference bounding box and the annotation bounding box. This value reflects the accuracy of the model in detecting the corresponding target. Inference mode. Select the processor type for model inference, with options including CPU mode and GPU mode. After configuring the test parameters, model testing can be performed. You can view the task status in the Task Manager. Finally, users can evaluate and optimize model performance based on test metrics such as precision recall and inference time. They can also assess the model performance using the Confusion Matrix Summary. Step 5. Model Conversion. For Vision Master Platform, the trained models can be directly imported into VM software for detection applications. Anyway, if the model is intended for use with smart cameras, the model file needs to be converted from .model to .bin, since the .model format is incompatible with smart cameras. Now, there are two methods to convert the model. 1. Offline conversion. Please contact technical support to obtain the offline conversion patch package. After installation, go to the System Settings, Software Setup, and Enable. Convert Model. VisionTrain will automatically trigger model conversion once training is complete, and the converted model can be directly applied to the corresponding camera series. 2. Online conversion. Contact technical support to obtain the overseas online conversion platform link. After registering and logging in, click Add New Conversion Task and select the corresponding platform to create a conversion task. Prepare the model file for model conversion. Upload the model file opening parenthesis .model format and the compressed package ZIP format containing images, labels, and training parameters in the designated file upload section for conversion. Click Convert to create a new conversion task. At this point, the model conversion interface will display the newly created task, allowing you to view its current status. Click Download to use the converted files once the conversion is complete. Step 6. Model Import plus Validation. Next, we will import the model to VM platform for validation. Select the corresponding module for the model. Choose Running, Parameters and Model File Path. Import the corresponding model file, and click Execute to view the model detection results. And we use SE3000 series camera as an example. Select the corresponding module, navigate to All Parameters gives. Model List gives Import, click Done, and proceed with testing and validation.